Kindly enable me for sharing the screen. Hello. Hello, can you hear me, ma'am? Hello.
Yes, sir. Yes, sir.
Enable me to share the screen, ma'am.
Yes, yes, sir. Please, I'll do that.
My
Sir, you can continue, sir.
Okay, ma'am. Hello, good evening, students. Can you see the screen? Is the screen visible to you?
Yes, sir.
Sir, could you please record it? Record in the cloud, sir.
It's recording already. It's recording. No, when
Okay, sir. Okay, then fine. Okay, sir.
already recording, I think. All right. So the welcome to the course in chemistry. The first chapter, it is the solid states. Now, as we understand, or as we have learned it in the lower classes, matter is something which occupies a definite space or volume and which has a definite mass will be called as matter. Matters are chemical substances or substances which occupies a definite volume and which has a definite mass is called as matter. For a chemist, matter exists in three states. That is the gaseous state, liquid state, as well as the solid state. So the other states we do not talk about in chemistry. We talk about only three states of matter. One is the gaseous state, the other one is the liquid state, the third is the solid state. The chapter what we're going to learn is about the solid state. Before getting into the topic, the solids, we should know the difference between gases, liquids, and solids. Now, if the particles are far away from each other, when we talk about particles, the particle can be referred to atoms, it can be referred to molecules, or it also can be referred to ions. So molecules can be, particles can be any of these. So when the particles are far away from each other, then they behave like gases. We will see why the particles are far away from each other. All that we will learn in a few minutes now. Now, if the particles are nearer to each other, they behave like liquid. And if the particles are nearest to each other, then they behave like solids. I told you, matter is something which has a definite mass and which occupies definite space or definite volume. There's a space, sorry, there's a space. Definite volume will be called as matter. And we have three states of matter: solid, liquids, and gases. In case of gases, the particles, the atoms, the molecules or ions are far away from each other. When the distance is more between the atoms or the molecules, then they behave like gases. When the distance are closer, nearer to each other, they behave like liquids. And if the particles are close to each other, they behave like solids. Now, the relative energies of these different states of matters, the relative energies of liquid, gases, and solids, they depend on two forces. When we say two forces, one is called as mutual attraction, tendency of mutual attraction. And the second one is the escaping tendency. So the relative energies of different states of matters depend on two factors. One is the mutual attraction between each particles or the escaping tendency of each particle. Now, if the escaping tendencies of each particles are greater than the attraction, mutual attraction, then they behave like gases. Now, you should know that if the atoms or the molecules have more escaping ability or escaping tendency compared to the attraction tendency, then they behave like gases. Are you with me, students?
Yes, sir.
Yes, sir.
Yeah. In case of liquids, the molecular attraction exceeds the escaping tendency. So molecular attraction, the molecule will come close to each other. So if the molecular attraction exceeds the escaping tendency, then the matter behaves like a liquid. And in case of solids, the force of attraction, mutual force of attraction, is much greater than that of the escaping tendency. When the mutual force of attraction is much greater than the escaping tendency, then the matter behaves like a solid. Now, if the escaping tendency is greater than the mutual attraction, then the matter behaves like gases. If the escaping tendency or the attraction tendency exceeds the escaping tendency, then it behaves like a liquid. If the mutual attraction of a molecule exceeds than the escaping tendency, then the matter behaves like solids. Now, how do we define a solid? Now, in general, solids are substances which have definite volume and definite shape. See, in case of solid, the mutual attraction exceeds than the escaping tendency. Therefore, the particles, when we say particles, I told you in the beginning, it can be referred to an atom, it can be referring to a molecule, or it can refer to an ion. When the particles are arranged in the definite order, the particles will be arranged in the definite position otherwise, then we call them as solids. That is why the solids have a definite shape. And they also have a definite volume. Solids are substances which have definite volume and definite shape. In solids, the particles, the atoms, molecules, or ions are held together by strong force of attraction. Therefore, the particles are present in a regular fixed position. Hence, a solid have definite geometry. Now, for an example, if I represent a particle like this, see these dots, what I'm representing is nothing but a particle. Now, if I join these particles through a bond, this is a chemical bond, okay, force of attraction. And you can see there is a cube formed. This is a cube. So these are the particles. Cube has 8 corners. In the corners, we have particles like this. This dot, what I'm representing, those are called as particles. So particles are orderly arranged and they are having a strong force of attraction. Since they have strong force of attraction and they have fixed position, they have a definite geometry. Unlike liquid and gases, the escaping tendency are more in case of gases, but attractive tendency is more in case of liquids, but not as that of solids. Therefore, liquids and gases, they do not have definite geometry. In case of solids, they have definite geometry because the particles are held through a strong force of attraction, and these particles are held or having a fixed position, therefore they have a definite geometry. Did you understand this, students? Kindly interact with me, talk to me. Are you following?
Yes, sir.
Others? Others?
Yes, sir.
Yes. Now, what are the characteristics of the solids? The general characteristics of solids. Now, solids have definite mass, I told you, and it occupies a definite volume, and also it has a definite shape. Any solid for that matter, they will have a definite mass, they have a definite volume, and they also have a definite shape. And solids have short intermediate distances and strong intermolecular force of attraction. In case of solids, the particles will have strong intermolecular force of attraction. Since they have a strong intermolecular force of attraction, they are hard. Any solid for that matter, they are hard. They are rigid. They are rigid. The solids have short intermediate distances and they have strong intermolecular force of attractions. Therefore, any solid for that matter, they will be very hard and they are rigid. The constituent particles of the solids, whether it's an atom, it's a molecule or ions, they have fixed positions and can only oscillate about their mean position. So they have this, you don't worry, oscillate only about their mean position. This concept you don't have to worry. Now it says the particle in solids, the particles have fixed positions. That is why they have definite geometry. And the next point is solids are incompressible and rigid. We learned it in the previous point, because in solids, the strong intermolecular forces, they are very hard and they are what, rigid. The other point is they have sharp melting point. They have sharp and high melting point. Sharp and high melting point. We will learn what is melting point a little later, and why we are talking about sharp melting point. We will learn that also in the following sessions a little later. Next, in case of solids, the particles do not change their positions. Hence, it cannot be poured. You can pour a liquid. If you take water, you can pour it. But in case of solids, we cannot pour because the particles do not change their positions. Particles do not change their positions. Since the particles do not change their positions, they cannot be poured. They cannot be poured. These are the characteristics of the solids. So solids have definite mass, volume, and shape. They have strong intermolecular force of attraction. And in case of the solids, particles are in regular fixed positions. So they are incompressible, hard, and rigid. They have sharp melting point, and they are having a high melting point, and particles do not change their position. Therefore, they cannot be poured. Is it okay, students? Have any clarification till here? Till here, any clarifications?
No, sir. It's fine, sir.
Others?
No, sir.
Anybody? Okay, good. Classification of solids. How solids are classified? Solids are broadly classified into two. One is the crystalline solid, the other one is amorphous solid. Crystalline solid, and the other one is amorphous solid. Now, what are these crystalline solid and amorphous solid? Now, based on the presence of or the absence of the orderly arrangement, solids are classified into two, crystalline and the presence or because of the presence or the absence of orderly arrangement. Orderly arrangement of their constituent particles. So due to the presence or absence of the orderly arrangement of the constituent particles, solids are classified broadly into two, amorphous solid as well as the crystalline solids. Now, this is important. important. This differences between the crystalline solids and the amorphous solid is important for a board. Differences between the crystalline solids and the amorphous solids. Okay. In case of crystalline solid, long range orderly arrangement of constituents. In case of crystalline solids, the particles are orderly arranged for a long range. In case of amorphous solid, particles are arranged orderly only for a short range or random arrangement of constituent particles. We will take examples and we'll try to understand this a little later. Now, in case of a crystalline solids, the particles are orderly arranged for a long range. And in case of amorphous solid, particles are arranged orderly only for a short range, or we can simply understand that particles are arranged in random. And the second difference is, in case of crystalline solid, all crystalline solids will have definite shape. All crystalline solids will have shape. They will not have a definite geometry. They will not have a definite shape. They will have irregular geometry. And the third difference is very important difference. Crystalline solids are anisotropic in nature, and amorphous solids are isotropic in nature, like liquids. What is this anisotropic? Now, for an example, if we take an iron rod or an iron plate or something like this, it's assumed that this is an iron. Now, iron is a good conductor of heat and electricity. Yes or no? Any metal for that matter, it's a good conductor of heat and electricity. Are you guys there? Students, metals are good conductors of heat and electricity. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Participate in the class.
Sir,
Now,
your voice is breaking, sir.
my question is, I am heating this iron rod, which I've
Excuse me,
placed,
sir. Sir, your voice is breaking in between, sir.
maybe because of the rain network issue, it should be, ma'am.
Yes, sir. Yes, sir.
I think so. Now, if we heat at this particular point, assume that we're heating this iron rod at this particular point. You tell me the time required for the heat will it be same or different? Heat to travel this distance and heat to travel this distance, will it be same or not? Hello? Hello?
So could you repeat the question, sir?
Yeah, time required for the heat to travel this distance and this distance, will it be same or different? I'm heating it in this corner. Time required to travel this distance and time required to travel this distance, will it be same or different? It's a simple question. Huh?
So different, sir.
Different, yes. So physical properties, when measured in different direction, if it is different, they are called as anisotropic. This is an important question. What is anisotropic? Physical properties measured in different angles or different directions. If they are different, they are called as anisotropy. Now, example for anisotropy, refractive index is an example for anisotropy. Okay, electrical conductivity and thermal conductivity, heat. These are the examples for anisotropic substances. They will be different in different direction. But coming to amorphous solid, in case of amorphous solid, the physical properties, if you measure it in any direction, it will remain same. Therefore, they say they are isotropic and they're mentioned like a liquid. In case of liquid, you measure the property from any direction, it will remain same. Those are called as isotropic. Now, crystalline solids, they are called as true solids. The fourth difference is The crystalline solids are called as true solids, and the amorphous solids are called as false solids or pseudo solids, or it is also called as supercooled liquids. Amorphous solids are also called as supercooled liquids. Now, crystalline solid, the next one difference is the crystalline solid, they have definite heat of fusion. Fusion is similar to melting point. Fusion point is similar to melting point. When a solid starts melting, that's called as a fusion point or fusion temperature. So in case of crystalline solids, they have a definite heat of fusion. And in case of amorphous solid, the heat of fusion is not definite. It is similar. Now, the next point, in case of crystalline solid, the solids have a sharp melting point. What do you mean by sharp melting point? At a particular temperature, any solid will get converted into a liquid. At one particular temperature, all the solid will get converted into liquid. Those kind of solids are crystalline solids. That is why they call it as sharp melting point they have. In case of amorphous solid, they gradually soften over a range of temperature, so it can be molded. In case of amorphous solid, there will be a range in melting point. When I say there will be a range in melting point, they will start melting at one temperature and completely melt at another temperature. Therefore, they have a range of melting point, a range of temperature. Therefore, they can be molded into different shapes. Now, for an example, plastics. On heating a plastic or heating a glass, if you remember the first experiment, what you would have done in 11th, the glass works in the laboratory. They would have taught you to bend, they would have taught you to stretch the glasswares. So if you heat any tube, glass tube, or any material, glass, it softens. When it softens, you can mold it into a desired shape because they do not have sharp melting point. Examples for crystalline solids. Crystalline solids, NaCl, sodium chloride, diamond is an example for a crystalline solid. And for amorphous solid, the few examples are rubber, plastic, glass, etc. These are the examples for the amorphous solid. Any clarifications here? Any clarifications here?
No, sir.
No, sir.
My video is not working properly. All right, so I'm not able to. Any other students, any clarifications? Did you understand the difference? Now, we should know the theory before we talk about the MCQs. So that is why I'm going slow teaching you the theory part. Is there any clarification still now?
No, sir.
Anybody?
No,
Now, crystalline solids are further classified as isomorphous form. The crystalline solids are further classified as, the first one is isomorphous. Iso means same. Morphous means form. So isomorphism is a process or a phenomena in which two or more substances having same crystal structure. Two or more, what is isomorphism or isomorphous solid? Two or more substances having same crystal structure will be called as isomorphous solid, and the phenomena is called as isomorphism. What are isomorphism? Two or more substances having same crystalline structure will be called as isomorphous solids, and that phenomena is called as isomorphism. In case of isomorphous substances, the constituent atoms will have same atomic ratio. Now, what does it mean? In case of isomorphous substances, the constituent atoms of the isomorphous substance are in the same atomic ratio, in the same atomic ratio. We will take an example and understand. Examples will take isomorphous substances and the atomic ratio. Isomorphous substances and the atomic ratios. Now, for an example, the first set is sodium fluoride and magnesium oxide. You can see in sodium fluoride, we have two different types of atoms. One is sodium, the other one is fluoride. In case of magnesium oxide, we have magnesium as well as oxygen we have. What are the atomic ratio here? The atomic ratio here is 1:1. What do you mean by 1:1? One sodium, one fluoride ion. One cation, one anion. Here also, one magnesium ion, the other one is oxygen ion. I'm calling it as an ion because sodium will have a positive charge here and fluorine will have negative charge. Here, magnesium will have +2 charge and oxygen will have -2 charge. We will talk about ions all that little later. We would have learned it in the 11th standard, but we will learn about the concept ions later. Here, the ratio is 1:1. If you take the next example, if we take sodium nitrate, NaNO3, and if we take calcium carbonate, here the ratio is what? What is the ratio of sodium? Ratio metal here. The metal here is 1. The next element is nitrogen. That is also 1. And here it is carbon. It's nitrogen here, it's carbon. And oxygen ratio is what? 3. 3 oxygen atoms we have. Here also 3 oxygen atoms. Therefore, the ratio is 1:1:3. Now, you should tell me with a third example. Now, if you take potassium sulfate, K2SO4, and if you take potassium selenate, K2SeO4, selenium is Se. What is the ratio here? The ratio will be what? Anyone tell me? Anyone just participate?
2:1:4.
Very good. 2:1:4. 2:1:4. These are called as isomorphous substances. These are the examples for isomorphous substances. What are isomorphous substances? Two or more substances having same crystal structure. That means sodium fluoride and magnesium oxide will have same crystal structure. Sodium nitrate and calcium carbonate will have same crystal structure. Potassium sulfate and potassium selenate will have the same crystal structure. And that phenomenon is called as isomorphism. Isomorphism. Is that possible to understand, students?
Yes, sir.
Yes, sir.
Now, continuation. The next classification is polymorphous. Polymorphous or the allotropic forms. Allotropic forms. What are polymorphs or what are allotropic forms? A single substance that crystallizes into two or more forms are called as polymorphs, or called as polymorphous substances. Now, poly refers to many. Poly refers to many, and morphous, we know that it means forms. A single substance, if it can exist in more than one form, then they are called as polymorphs. They are called as polymorphs. For an example, we know that diamond and graphite, this diamond and graphite, both are made of what? Diamond and graphite, both are made of what? Diamond and graphite, both contains
Carbon.
what otherwise?
Carbon.
They are made of carbon. Now, diamond has a different structure, graphite has a different structure. So when we say polymorphism or allotropic form, a single substance a single substance that crystallizes in more than one form under different conditions. The conditions should be different. Under different conditions are called as polymorphs or allotropic forms. Example, like if you, one of the example we gave is diamond and graphite. Likewise, we have another example, rhombic sulfur. We will learn the structures of all this little later, rhombic sulfur and monoclinic sulfur. So sulfur is common, but the structures are different. These kind of substances, a single substance that crystallizes into more than one form is called as polymorph, or it is called as allotropic forms. On the basis of the nature of the constituent particles and the interparticle forces, crystalline solids may be classified into four classes, four types. What is that I told you? Based on the nature of the constituent particles. First one is nature of the constituent particles. Based on the nature of the constituent particles. Second one is intermolecular forces or interparticle forces. We do not want to mention it as molecular particle because it can be atom or a molecule or an ion. Intermolecular forces. Crystalline solids are divided into four classes. What are the four classes the crystalline solids are classified? They are classified into molecular solid, ionic solid, metallic solid, as well as the covalent solid. So based on the nature of the constituent particles and the interparticle forces, crystalline solids are classified into four. What are the four? The first one is molecular solid. The second one is covalent solid. The name itself should give you the explanation. The third is metallic solid. And the fourth is ionic solid. So based on the nature of the constituent particles and the interparticle forces, crystalline solids are classified into molecular solid, covalent solid, metallic solid, as well as the ionic solid. We will learn in detail about all these. Now, the first one, molecular solid. Now, what is that you understand by the term molecular solid? What do you understand by the term molecular solid? Anybody? Now, the question I can put it in this way. In case of a solid, we know that. Now, in case of a molecular solid, what will be the particle? Whether it will be an atom, it will be an ion, or it will be a molecule.
Molecules.
So if I write a cube like this, for our understanding, if I write a cube, if I draw a cube like this, and if I say in the corners of the cube, there are molecules, then this solid will be called as a molecular solid. So a molecular solid will be made of molecules. Molecular solid will be made of molecules. Now, in case of molecular solid, the force of attraction will be weak. The force of attraction will be weak. So in case of molecular solid, see the property here. The constituent is molecule. It's already given here in the slide. Okay, the constituent particles are molecules. The attractive force in case of molecular solid is a weak van der Waals force of attraction. Weak van der Waals force of attraction, or dispersion forces, or London forces. So force of attraction in case of molecular solid will be weak. Will be weak. And examples for a molecular solid: hydrogen, H2, iodine, carbon tetrachloride. You would understand that hydrogen is a gas, carbon tetrachloride is a liquid, but this also can have a definite geometry at different conditions. Therefore, they are given examples as a molecular solid. So a few more examples if I have to give. a solid neon. Neon is a noble gas, solid neon, solid ammonia, solid ammonia. All these are examples for solid carbon dioxide also you can take. Solid carbon dioxide. All these are examples for a molecular solid. Now, what is the physical nature of the molecular solid? The physical nature of the molecular solid is soft. They are soft and they have a low melting point. The melting point is very low. At very low temperature, they will melt. And they are insulated. They do not conduct electricity. Therefore, they are called as an insulator. So molecular solids are solids in which the particles are molecules. These molecules are held together by a very weak intermolecular force of attractions like London forces or dipole-dipole interactions or van der Waals force of attraction in simple terms. Example, solid neon, solid ammonia, hydrogen, solid hydrogen, iodine, carbon tetrachloride, solid carbon dioxide. And their physical nature is soft and they are insulated. They do not conduct electricity and the melting point is very low. These molecular solids are classified into two. One is non-polar and polar. If you look at the slide, you can clearly tell what is polar, non-polar. Examples are given here. Now, what is polarity? Now, if you take HCl, hydrogen chloride for that matter, the electronegativity, the concept electronegativity, you should understand. What is electronegativity? The ability to attract the electron towards itself is called as electronegativity. So to form a covalent bond or to form a bond, any bond for that matter, we require two electrons. So I'm representing two electrons here like this. Now, since chlorine is highly electronegative, what will happen is it has a tendency to attract electron towards itself. These electrons will be pulled towards chlorine. When these electrons are pulled towards chlorine, this chlorine will gain partial negative charge. Since electrons move away from hydrogen, this hydrogen will gain partial positive character. So two poles are developed in a molecule. Two charges are developed in a molecule. Therefore, this hydrogen chloride will be an example for a polar molecule. So if you have hetero atoms in a molecule, different atoms in a molecule, then those molecules will be generally polar. Now, if you take hydrogen gas, H2, now this hydrogen is also bonded through a covalent bond like this. Two electrons are here. The electronegativities of these hydrogen atoms are same. So these electrons will not move towards the hydrogen on the right, or it will not move towards the hydrogen which is on the left. Therefore, they will not have any charge difference. They will not have two poles developed in the molecule. Therefore, this hydrogen molecule will be an example for a non-polar molecule. Homoatomic molecules. Homoatomic molecules. Homo stands for same. So if a molecule is made of similar atoms, homoatomic molecules, then those molecules will be non-polar. If the molecules are made of heteroatomic molecules, then the molecule will be polar. So now molecular solids are of two types, non-polar as well as polar solids. Now, in both the cases, whether it's a non-polar or polar molecule, molecular solid, the constituent particles are molecules and weak van der Waals force of attraction. Here in case of non-polar, it is dispersion forces or London forces. In polar molecule, it's dipole-dipole interaction. Dipole-dipole. Here you can see there's dipole. In HCl, it's dipole. If I write HCl like this, another HCl I can write like this. So what happens? Here this is positive, this is negative, this is positive, and this is negative. Therefore, what happened? There will be an interaction. So this is called as dipole-dipole interaction. So in case of polar molecules, the molecules, a polar molecular solid, the molecules are held together, dipole-dipole interaction. Example for a polar molecular solid HCl, SO2, and they are again soft, they are insulator, and they do not have a high melting point. They have low melting point. Is there any problem with this molecular
No, sir.
solid? Hello?
No, sir, no problems.
No issues so far? I think I'm audible to all. Yes or no?
Yes, sir.
Yes, sir.
Yes. And the next is again a molecular solid which can be formed through hydrogen bond. Third is molecular solid which is formed through hydrogen bonding. So again, the particles are molecules here, and the nature of bonding is hydrogen bonding. You know what is hydrogen bonding. Example, water, which is in solid state called as ice, and this ice is hard. That everybody would know this. You would have handled ice cubes, at least at home. It is hard, and it is an insulator, and the melting point is very low. At just above 0 degrees Celsius, the ice which is in solid form gets converted into a liquid form. So in case of water molecule, water has a bent shape or V shape, the structure geometry. If we represent it like this again, so the bonding between hydrogen and highly electronegative atom like oxygen or nitrogen or fluorine is called as hydrogen bonding. See, hydrogen bonding is represented by a broken line. It is not a straight line like this. So generally hydrogen bonding is longer. Remember, hydrogen bonding is longer. So ionic solid, in case of hydrogen bonding molecules, the bonding between the particles are hydrogen bonding. Example is water, and they are hard, insulator, and the point is very low. The next type of solid is ionic solid. The name clearly says, in case of ionic solid, the particles are ions. When we say particles are ions, anything which have a charge will be called as an ion. Now, for an example, if I take sodium chloride, sodium will have a positive character and chlorine will have a negative character. This ionic bonds, we'll explain it in the chemical bonding chapter, all that little later. Ions are charged species. Charged particles are called as ions. So here, sodium will have a positive character and chlorine will have a negative character. Positive character is called as cation. Ion which move towards cathode. Cathode is a negative electrode. So positive ions will move towards cathode. So all positive ions will be called as cations. All negative ions will be called as anions. Anions means ion which move towards anode. Anode is a positive electrode. Now, when we have opposite charges, there will be a force of attraction. That force of attraction is called as electrostatic force of attraction, or this is otherwise called as ionic bonding. It is otherwise called as what? Ionic bonding. A solid formed through ionic bonding or a solid formed due to ions will be called as an ionic solid. Example, a very simple example, sodium chloride. We referred here, sodium chloride is an example for an ionic solid. Ionic solids are hard. Sodium chloride is a common salt. What is used in the kitchen is sodium chloride. The salt what we eat is nothing but sodium chloride. You would have, nowadays we get fine powdered sodium chloride, and we have something called as rock salt also. You would have heard of rock salt. That rock salt will be very hard. You cannot powder it by applying force. Okay, it's hard. So any ionic solid for that matter, it's very hard. These ionic solid are insulator in solid state. When I say insulator in solid state, they do not conduct electricity when sodium chloride is taken in a solid form. But they conduct electricity in the molten state or an aqueous state. If sodium chloride is put in water, you take a beaker, you take sodium chloride, Here the sodium chloride is solid. Okay, and immerse two electrodes here, anode and cathode, connected to a power supply. Now you switch on the power supply, and I am asking any one of you to put a hand inside this. If you put a hand inside this, what will happen? What will happen? Participate in the class.
Shock.
No, you will not get a shock. I'm using solid sodium chloride. In solid sodium chloride, sodium and chlorine ions are held together by an electrostatic force of attraction, ionic bond. Therefore, these ions will not move towards the respective electrode. That is why they say it is an insulator in what state? Solid state. Now, if you add water to this, what happens? It becomes a solution. When you add water to sodium chloride, what happens? the sodium chloride will disassociate to form sodium plus and sodium minus, chloride minus, Na plus and Cl minus. Now in solution state, you will have Na plus as well as you will have Cl minus. Cl minus will move towards anode, Na plus will move towards cathode. Due to the movement of these ions, what happens? You will get shock. It will carry current. So ions are charge carrier in solution states. Since they carry current, what happens? When you put your finger into it or put your hand into it, what happens? You get a shock. That is why they say they are state or an aqueous state. Aqueous state means solution state. And their melting point is very high. Ionic solid, the melting point is extremely high. Why extremely high? Because they are hard, very hard, strong force of attraction. Therefore, ionic force of attraction. It is not hydrogen bonding. In case of water, even though it is hard, the bonding is hydrogen bonding. Therefore, they have low melting point. But in case of ionic solids, the force of attraction is electrostatic force of attraction, ionic bonding. To break the force ionic bond, the energy required is very high. Therefore, the melting point is very high. The next what we have is metallic solids. Metallic solids. What do you mean by metallic solids? A solid made of metals, only metals will be called as metallic solid. Now, kernels in the sea of electrons. What are these kernels in the sea of electrons? Now, what do you mean by this kernels in the sea of electrons? We'll understand this. Now, any metal for that matter, this copper will lose 2 electrons. You should know the atomic number and electronic configuration. We will learn all that in detail a little later. Now, for now, you remember copper metal will lose electrons because metals are electropositive. They have a tendency to lose electrons, donate electrons. So this copper will donate electrons and get a positive character, Cu2 plus. Now, any metal with positive character will be called as kernels. Any cation for that matter will be called as kernels. These cations, kernels, they are surrounded by sea of electrons. When we say sea water, we cannot measure. Likewise, if these positive ions are surrounded by many number of electrons, this is called as a metallic bond. This is called as metallic bonding. So kernels refers to positive ions, cations. These cations are immersed or present, are surrounded by a more number of electrons, sea of electrons. So the bonding between the metallic solid is a metallic bonding. Metallic bonding. When we say metallic bonding, it's a force of attraction between metal ions and electrons. That's called as metallic bonding. Example, iron, copper. Any metal for that matter, it's hard. They are a good conductor of electricity and their melting point is very high. The melting point is very high. We learned 3 types of solids now. One is molecular solids. In molecular solids, the particles are molecules. In ionic solids, the particles are ions. In metallic solids, the particles are kernels. Kernels means positively charged ions surrounded by a definite large amount of electrons or more of electrons, sea of electrons, they say. Now, the last type of the metallic solid, what we have is called as covalent solid, or it is called as Tanushri. What is this message? What is this message? What's that? I didn't understand. Tanushri. Covalent or network solid. Covalent solid or network solid. In a network solid, the particles are atoms. These atoms are held together by a covalent bond. By a covalent bond. By a covalent bond. So covalent or network solid, the particles are atoms. Just we learned example, diamond we learned, graphite we learned, and this, now they've given silica, SiO2 is silica. So the particles are held together, the atoms are held together by covalent bonding. Covalent bonding is formed by sharing of electrons. So covalent, carbon, diamond, they're hard or soft. you cannot generalize covalent solid. It can be either hard or it can be soft. They are insulated. Generally, the covalent solids are insulator and their melting point is very high. Diamond is the highest, hardest substance having a very high melting point. Any clarification with this? So
No,
far,
sir.
if you do not have clarification, we will continue. Some of the questions we'll learn possibly in the next class. You can revise all this. Madam, can I stop for now? Hello? 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 Students, any clarification? You can get clarified, because I don't want to continue the next topic because it may take time.
No, sir.
Others? Others, any clarification?
No, sir.
No, sir.
Okay. 1 minute, 1 minute. Okay, no, sir.